Hi, my name is Sarah Pascarella, and I am going to be discussing my database proposal regarding critical care hospital bed availability in Minnesota. The objectives that I'm going to be discussing include the planning, analysis, system design, implementation, maintenance regarding the database. And then I'm going to be discussing elements of the proposal, like its purpose, the intended users, the project's goals and objectives, the database schema components, the database functions, policies, procedures, and regulations, potential problems, and feasibility. So the project problem, basically there's a need to know the exact amount of critical care beds available for critically ill patients in Minnesota. There's a need for a database in Minnesota to compile and report the availability of critical care beds throughout the state. This database is proposed to allow easy access for the availability of critical care hospital beds. The goals and objectives. So the goal is to obtain available ICU and ER beds from all 87 counties by August 31st, 2022. The objectives for this database are to be able to capture and store data of available critical care beds in real time, identify trends, patterns, and relationships, and then track the percentage of hospitals within each county from which the data has been obtained. So planning. It's important to determine feasibility, define the problem, determine objectives, determine users, secure funding and available resources, and set the project schedule for the database, as well as prepare SRD documents that is complete and strategic, and perform structured and unstructured interviews, review existing procedures and records, and utilize joint application development. So for policies, procedures, and regulations, I plan to utilize blockchain technology. This database will not include specific EHRs or PHRs, which will be helpful with maintaining HIPAA. However, maintaining HIPAA will be embraced by the privacy rule in order to protect any PHIs. And then I plan to evaluate requirements of the privacy rule are being met within the database, and to identify and analyze any potential risk like cyber attacks. And then through that, that also encompasses utilizing security personnel. And I plan to implement training to workforce members and users and limit the physical access to the database. So who are the database users? So I plan to create a data quality team, which would encompass a business analyst, enterprise architect, a business application owner, a process manager, possibly a management system owner, an information consumer, and importantly, a data security officer. So who's going to be the ones using this database? Mostly healthcare providers, but also possibly some registered nurses, like especially those that are charge or lead nurses. So analysis. So analysis is important for the database. So SRS documents and software applications need to be created. Specific details regarding the database need to be gathered as well as evaluate any existing databases regarding this type of information, maybe possibly done in other states, and research and analyze the needs of end users, so like the healthcare providers and nurses previously discussed. So the analysis of specific data. So I'm going to be analyzing the amount and names of counties in Minnesota, as well as the names of hospitals within each county, and then the potential ER and ICU beds at each hospital, and then the available ER beds at each hospital. It's important to utilize structured analysis through graphics and utilize tools like data flow diagrams and data dictionaries at this point in the database proposal. So reports. The reports that I will be creating is a baseline analysis, and then a cross-domain analysis report, and a data quality report. So the system design. So how is this database going to be implemented? At this point, SRS documents are put in a format that can be implemented. Database infrastructures and organizational changes are put into place, as well as data schema. Metadata is collected, and a database prototype is created as well. Entity relationship modules are utilized to help describe the entities, and system documentation is the technical specification to describe each program and function and include the data through things like object models, screen layout, things like that. The system documentation is created during the system analysis and design phase, and then also training and methodologies are put out, like system overview, the description of the database content, security, audit trails, things like that. Also how to report problems or request any changes, and start answering any frequently asked questions. So the database schema components. So begins with developing a data flow structure and connecting database schema. 5 primary entities were identified. Dimensional entities like counties and hospitals, and then fact entities like quantity of beds, total available beds, and immediate bed availability. At this point, we utilize dimension and attribute tables from the database to collate the number of beds available in Minnesota. There'll be 3 attribute tables for storage of information for immediate availability, potential availability of beds, and then subsequent aggregate for total availability of beds in Minnesota. And then there'll be 2 dimension tables, the county ID and the hospital ID. And the county ID will be connected to all other tables in the database in order to be able to enable queries to run at any of the hospitals with a selection of either hospitals, immediate availability, or total availability. So this is my entity relationship diagram for my proposed database. It's a crow's foot with a star schema. As you can see, the county ID is connected to the hospital quantities, potential beds, and bed availability total. So this is my system design data dictionary. It includes the hospital name, the county name, the hospital ID number, the county ID number, total ICU beds, and then also total ER beds, and then total available ER and ICU beds. Okay, so these are some of the database functions, like creating a table and then inserting the county names and then selecting from the county. And this is another database function about altering a table. As you can see, the described counties are altered. So it has the ID, the county name, and then the state, which will, in this instance, be Minnesota. Here's another database function where we just selected the county name from the counties. This is another database function where the hospital name is selected from the county. This is another database function where columns were added. So it has county ID, county name, total beds, and available beds. And this is another database function where I was able to create a sum of the available beds, total available beds in Minnesota. So the implementation for this database will start with constructing the actual database, then verifying the database is operational, then providing appropriate training to personnel and system operators, then utilize some peer review evaluation to see what, end users are thinking about this database. And again, like I stated, include users in the review process. So next I'll be discussing the database's maintenance. So I'm going to be using maintenance to restore and enhance the database itself, and then embrace 3 types of maintenance: corrective, adaptive, and perfective. So these are important to be able to repair and correct problems, replace functions, and then modify and enhance the database. So potential problems and barriers. Some potential problems and barriers that I identified include obtaining accurate information regarding the number of available ER and ICU beds. Maybe some hospitals will choose not to participate. And then obtaining real-time availability of ER and ICU beds. And hospitals not participating, like I mentioned, in sharing their availability of ER and ICU beds. So this database's value. So this database is valuable. It became very apparent with the recent COVID-19 pandemic to frontline workers, along with other, the public and other members of the medical community, with needing to know exactly how many critical care beds are available. Also, this database, the information hopefully won't be too difficult to obtain, because the only unknown data that will have to be collected and updated in the database by each hospital is their number of available ICU and ER hospital beds. Also, this database is valuable because it has several benefits, like providers can save time by simply logging into the database to view available critical care beds. I know during COVID, providers themselves were calling around to various hospitals to try to find their patients' beds. The cost. A typical database can range from $2,000 to $10,000, and then also has annual fees that can be about $500 a month for storage and memory. Plus, then there is the employee compensation. So, yeah, this database will help find critically ill patients the level of care that they need, and which will, in result, help improve patient outcomes. So at this time, I would ask if there were any questions regarding the database proposal. And then I just want to review that this database is imperative for knowing the amount of available critical care beds in Minnesota. COVID's kind of was on the decline, but I've seen myself that it's starting, we're starting to get more COVID patients. So it seems like it's inevitable at this point that we'll be dealing with something like this again. This database will be a huge value to our patients and the Minnesota critical care community. The database will help to improve patient outcomes by improving both patient safety and quality of care. And like I mentioned before, patients will have better outcomes because they'll be getting the care that they deserve. They won't have a hospitalist caring for them. Instead, they could have an intensivist or someone better qualified to care for them. So this will help reduce providers be pressured to take care of patients that they weren't comfortable taking care of like they had to do during the initial COVID-19 pandemic. And these are my references. Thank you. Have a good night.